Hello everyone. So today we're going to recap a topic that you may have learned in your previous work, and that topic is the Pythagorean theorem. Now, the Pythagorean theorem might just be one of the most famous mathematical formulas, and perhaps you've seen it before. It's a squared plus b squared equals c squared, right? But you do have to remember what this formula means, like what do all the letters mean? So first of all, this formula only applies to right triangles, not just any triangle. So here's an example triangle, and let's say this angle right here is 90 degrees. And remember that this little square thing indicates that that angle is in fact 90, right? 90. And now you also have to remember what the letters A, B, C represent. And the key here is remember that C represents the hypotenuse, right? The longest side, the side opposite the 90 degrees. So the 90-degree angle is at the top, and then the side opposite that is this long one here, right? And so in a right triangle, the side opposite the 90 degrees is called the hypotenuse. Hypotenuse. And that is the side length that is C. And once you establish that, now you can say, okay, the other two side lengths, A and B, well, it doesn't matter. Either one can be either one, as in, let's say this one's A, this one's B. We could also say the left one's B and the other one's A. So once you've established which one's C and also the other two sides, then you can start plugging in any known side lengths into the formula. So let's do an actual example with specific numbers. So here we've got a right triangle and it says calculate the value of x. And again, since it's a right triangle, we can use the Pythagorean theorem. So let's start with that. A squared plus b squared equals c squared. And again, remember it's super important that you establish which side length we put under c, right? And that's the hypotenuse. So out of 12, 35, and x, which one is the hypotenuse? Which one is opposite the right angle or the 90-degree angle? Well, it's x, right? Because here's the 90-degree angle, and across from it, boom, that's x. So what we do is we put x, or we replace c with x squared. And then the other two sides, 12 and 35, in any order, we plug those in for a and b. So 12 squared plus 35 squared. And now we just use algebra to solve for x, as in to get x by itself, right? Because in using order of operations, 12 squared, we can figure that out. That's just 144. Plus 35 squared, again, that's just a number. In a calculator, we get 1225 equals x squared. And then these are two numbers we can add, right? 144 plus 1225 is 1369 equals x squared. And then we want to get x by itself, so we have to cancel this square, right? Power of 2. How do you do that? What do you do to both sides to cancel squaring? Well, you square root. So square root both sides, and you get x equals, and you can stick square root of 1369 in your calculator, and you'll get a clean number, exactly 37. So our answer just happens to be a clean number in this case. So next up, we have another similar problem, but there's a bunch of little issues that will come up, so I'd like to talk about those. So the example is, how long is the unlabeled side? And we're working with a right triangle here, right? But I just want to remind you that in many math problems, you'll have to figure out what it is they're asking, what it is they're asking us to find, what we need to calculate, right? So the unlabeled side, you look at the problem and go, okay, here's our unlabeled side. And that the length of that is what we want to find, right? So that is our unknown. So what we do is we go ahead and let's label that side length with a variable like x. You can use whatever letter you wish. And now again, it's a right triangle. We're working with all three sides, so we can use the Pythagorean theorem, right? We got a squared plus b squared equals c squared. And again, you have to be careful which side length you plug in for c. Because again, c is always the one opposite the 90-degree angle. So here's the 90-degree angle, opposite that is a 14, right? So first off, we're going to replace the c with 14 to get c squared becomes 14 squared. And then the other two side lengths are a and b. And again, you can do them in any order. So let's just start with 11. We'll say 11 is a, so 11 squared plus b squared. The other side length is x, so it'll be x squared. And now again, we just have to use algebra to solve for x, right, to get x by itself. Now, how do we do that? So first of all, we got to get the x squared part by itself. And notice that there's some numbers we can just evaluate, as in some numbers we can simplify. Like 11 squared, if you evaluate that, you'll get 121 plus x squared, we don't know yet. We can't do anything with it yet. But then 14 squared is just a number, right? 14 squared is just 196. And then how do we get the x squared part by itself? Well, we got to get the 121 away. So subtract 121 from both sides. The 121s go away on this side. All we have left on the left side is x squared. And then that equals the right side, 196 minus 121, that's 75. And now again, how do we get the x by itself? How do we undo squaring? So again, square root both sides. So the square root and the square cancel, and you just get x equals. And here, let's talk about different ways we can write our answers. So you might think, okay, square root of 75. So just stick that in your calculator, and you'll get a messy number, right? Decimal approximation is around 8.66. But sometimes you'll want to, or sometimes you'll be asked to keep your answer exact, in exact form, as in with no rounding of digits. So notice that we're taking the square root of both sides to get square root of 75, right? To keep it in exact form, you might just say, okay, our answer is just the square root of 75, kept like that without plugging into our calculator. So again, square root of 75 is an exact form for our side length. But sometimes maybe you'll be asked to go even further, or maybe some standardized tests will give you the answers in a further simplified form, right? So the square root of 75, if you put it in simplest radical form, and in a previous lesson we learned how to simplify that with a tree and such, right? If you do that, you will get 5 root 3. So again, our final answer, our missing side length, is around 8.66, or to be exact, it's square root of 75 or 5 root 3, and that's 3 different ways of representing the same answer or same number. Now, one last example for you. It's similar to the others. Determine the value of x, and we're working with the 3 sides of a right triangle. However, you'll notice there's something weird going on. One of the side lengths, it says radical 20. So what is going on? Well, just know that radical 20 is just a number, okay? If you find a decimal approximation, you'll find that it is around 4.47. So we're just doing the same math, but with a radical as one of the side lengths. And so it goes the same way as the other ones. A squared plus b squared equals c squared. Just be careful which one's c. 6 is c, right? So a squared plus b squared equals 6 squared. And then what about a and b? So let's start with x. X can be a. And then the square root of 20, well, you're going to plug the whole thing into where b is. So you get square root of 20, all of that squared. Now let's start with the easy thing. 6 squared is 36. Then x squared we can't simplify. Plus square root of 20 squared. How do we deal with that? Well, remember that since square roots and squaring are opposites, they're inverses, we say, they cancel each other. So basically, you just get back that 20 as a normal number. The square root goes away, and it's just a clean 20. So now we have x squared plus a clean 20 equals a clean 36. Just subtract this 20 from both sides. These go away. You get x squared left over on the left side equals 36 minus 20 is 16 on the right side. And then again, how do you get the x by itself? Square root both sides. And you get x is the square root of 16, which happens to be a clean number, just 4. And by the way, one more thing. When you're talking about simplifying radicals, if it simplifies to a clean number, then that is simplest radical form, even though the square root, the radical goes away. So x equals 4, that's the answer, just as a clean number and in the simplest radical form. That's it for this lesson. As always, contact me if you have any questions or feedback.